Hello all, welcome back to my YouTube channel all about VLSI. In this particular video, we are going to start with the reference model discussion, where in the previous sessions we have started with read monitor, and write driver, read driver. We have completed those particular things. Now it's time for development of a reference model. Now, what do I mean by reference model? Reference model is going to act just like your design, whatever the design you're going to have, right? So that particular design you're going to replicate using the reference model. So let's say suppose if you have a DUT, your DUT is a RAM, which is basically of 128 cross 8 memory locations, right? Now, the same thing you're going to implement using the reference model. Okay. So you're going to implement it using the reference model where you're going to have 128 number of locations and each location is going to have 8 number of bits. Now, the RAM or whatever the design you are having, you are driving it using the right driver and write related signals you are driving it using the write driver, and read related signals you are driving it using the read driver. The same thing, your reference model also you're going to drive using the write driver. Now, but you're not going to directly connect write driver to the reference model, but you're going to use something known as a write monitor. So write monitor was basically collecting the transactions from your write driver, right? So using this write monitor, we are going to drive whatever the right driver has driven to your DUT, the same transactions we are going to drive it to our reference model, because we cannot drive the separate things to our design and reference model, and we cannot compare and we cannot say both are not working correctly, right? Both are not equally working, right? So whatever the transactions which I have driven using the right driver, the same transactions I'm going to collect it in my right monitor, and those same transactions I'm going to give it to my reference model. Same with my read driver, but not directly connecting my read driver to my reference model. I'm going to connect my read monitor, which is basically collecting the information which read driver was driving. So this reference model is going to have the same information which our drivers was driving to the design. Those particular same information was only I'm giving to my reference model. Now let's see how to develop my reference model. So I'm going to open the ED playground. The same playground I was using for all the particular files development, and I've also shared this in your group so you can check it out. Now, this particular reference model, let me declare the reference model over here, class ref underscore model. So RAM underscore ref underscore model, let me declare it over here. And let me declare the memory 7 down to 0, mem 0 to 127. Okay. Now, over here, let me declare the mailbox handles, transaction, reference model, write mailbox. So from write monitor, we are having one mailbox handle, and from read monitor, transaction, reference model, read underscore mailbox. And another mailbox, we are from the reference model, I'm going to send it to my scoreboard. About the scoreboard, we will discuss like what is your scoreboard and all. Expected mailbox. This is the handles which I have. Now let me declare few internal variables over here. Write underscore processor, read underscore processor are the two variables, and I'm going to have a new function which my environment uses to send this write mailbox handles and all. Okay. So I'm going to have the arguments as mailbox hash transaction reference model underscore write underscore mailbox. Okay. And one more argument, mailbox hash transaction reference model read underscore mailbox is one argument, and mailbox hash transaction reference model scoreboard expected underscore mailbox. So these are the three arguments which my environment is going to send it to me using this new function. Okay. And let me copy this dot reference model write mailbox is equal to reference model write mailbox, and this dot reference model read mailbox, which is equal to reference model read mailbox. and this dot reference mod scoreboard underscore expected underscore mailbox, which is equal to underscore mailbox. So this is what I'm copying it and followed by end function. Yes, and I've done this particular things now. Now what I'm going to do is I'm going to have a particular task which is for writing my data into the reference model. So how I'm going to write it down? So I'm going to have a task which is run underscore writes. This particular task is going to perform the write operation. Before that, let me create a transaction class, transaction, let tx, and let me display $display write task started. Okay. And more precisely, let's give the write task has been started from the reference model. Okay. Now, after that, what we are going to do within our begin block, I'm going to first of all get the data. Reference model, write underscore mailbox from the right monitor. I'm trying to get the data and I will store it in my TX. And after that, I'm going to write down the same data into the address which is specified in the txn dot address. So into this particular address only we were specifying or we were driving into the DUT. Same address we are captured inside my right monitor and I'm going to give it to my reference model so that into the same address I'm going to write the data. And the data will also be the same, whichever I was driving into my DUT using my right driver, the same data I'm capturing using my right monitor and I'm going to give it to my reference model. Okay. And after this, write underscore processor plus plus, I'm incrementing it and let me display the values of everything. $display. I'm displaying it from reference model. So write address is percentage hexadecimal format. Let me display and data is percentage h and followed by txn dot address and txn dot w data and followed by end task. And this is my and followed by end task. And I can also display the block address like data is percentage h and also I can display the block address. So block is percentage d. So block address, how I'm going to display it, txn dot address of 6 down to 5 will give me the block address. Okay. Yes. Now, next what I'm going to have another task which is known as read task for performing the read operations. So task reads, run underscore reads. So this particular task, what I'm going to do, first of all, I'm going to declare the transaction class handle. Let me declare two transaction class handles, txn comma expected underscore txn, which I can send it to my scoreboard. I can use the same thing for sending the data to my scoreboard. It's not an issue. $display reference model read task started. Next, what I'm going to do, I'm going to use a further begin block for this, and I'm going to use a mailbox handle dot get of tx. Okay, and I'm going to copy it. Expected is equal to expected underscore txn, which is equal to txn dot copy. So in the transaction class, we were having copy method, right? So that I'm going to copy it and I'm going to call it and I'm going to copy it into my exp underscore tx. Okay, I think I haven't declared any copy method in my transaction. Okay, not an issue. So let me declare only tx and handle, it's enough. Now after this, I'm going to txn dot r data, which I'm going to have. So into that particular R data, I'm going to read the data which is present at that particular address. So whatever the address which I was driving for read operation using this read driver, the same address I'm going to give it from the read monitor, and that particular address only we are going to read the data and we are going to store it into my R data. Okay, and also valid signal txn dot valid, it is equal to mem of, sorry, I mean txn dot valid, it is equal to 1. So valid signal, we only need to give it as one, right? After performing the read operation in that design also we have seen. And read underscore processor plus plus. Okay, that's it. And followed by end task. And before that, we need to have end. Okay, and that's it. And followed by end class. So that's it. This is how we are going to develop a simple reference model where it is going to perform the write operation and also the read operation. Okay. Yes. So that's about this particular session. And in our next session, we are going to discuss about how to develop a scoreboard and what it is going to do and all. We are going to discuss. Yes. Okay. So that's about this particular session. Thank you.